Hi, my name is Raz, and today I will present to you our latest work, ED-DCFNet, an unsupervised encoder-decoder neural model for event-driven feature extraction and object tracking. Event camera is a novel sensor that measures only motion in a scene. This new camera is based on asynchronous pixels with high dynamic range that outputs binary changes according to the intensity change in the scene. The rate of each pixel output is about 1 microsecond and has ultra-low power consumption. This camera also outputs grayscale frames for additional usage. Therefore, this camera is optimal for object tracking. Frame contains a lot of information, contrary to events, but events capture the changes. Therefore, by using both, the tracker's scores improves. Furthermore, we created a new, fully annotated indoor dataset. Our framework is based on UDT and DCFNet. First, we take events between frames and create a voxel from them, and take their corresponding frames. We do it 3 times in order to create our sequence. For each voxel and frame, we utilize an encoder-decoder network for extracting shared features with an encoder for each domain and a single decoder. Furthermore, because we know that DCFNet works on both event and frames, we use the DCFNet for each to enhance the extracted features and even combine them all. The frame does 2 forward tracking using correlation filter and then with an initial Gaussian label centered in the middle and the output response map as label for each tracking. Lastly, we do backward tracking. We can measure the loss using consistency loss between the initial response map and the latest response map, based on the assumption that the tracker will return to its original location in the center of the frame. We evaluate the tracker on both the new dataset and the OTB 2015 dataset. The new dataset was taken by an event camera with various camera conditions, such as daytime, and with various video lengths, ranging from 8 to over 200 frames to evaluate on. OTB dataset contains a total of 100 videos featuring a variety of attributes, including illumination, variation, and motion blur. We converted this dataset to events using EC, the event simulator. Our model results are comparable with the latest models, even though it is much smaller in size and unsupervised. Our proposed model, which integrates 2 DCFNets and an encoder-decoder architecture, is larger than a single DCFNet. However, despite its increased memory footprint, the proposed architecture maintains low latency, similar to that of the standalone DCFNet. For further details, we invite you to check our GitHub page. Thank you.